Hello, in this lesson, I wish to go over some of the factoring techniques that's commonly seen in calculus class, especially at this stage of study, where we're working on limit, and then soon enough we're going to be studying continuity. Factoring in calculus, the commonly seen factoring form is ax squared plus b plus bx plus c. Okay, you can see all of these situations are examples of quadratic. They're called quadratic function. Quadratic function. Okay, for quadratic function is a form that most likely you have studied in beginning algebra and intermediate algebra, and later these quadratic functions will will become even more useful in solving equations involve exponential logarithm and big equations. Okay, so quadratic function in terms of factoring, let's take some examples that we are familiar with, right? One form, you can see the first column here is that the a is equals to 1, okay? And in the second column, I pick some examples that a is not equals to 1 and a equals to, it could be any number, positive, negative, okay? And the question is that can we find the factors for any quadratic? The answer is yes. But I would like to start with some common techniques. So the techniques that were taught typically for the first one, okay, there are a variety of ways to do factoring in terms of setup. Okay, if you look at the elementary algebra, they have chapters of setup, and here I just use this one particular way, which I found very, very useful in most of the factoring needs we have. So I'm going to show you how it works. Okay, so when we have a equals to 1, right? So I'm going to put a row here. Okay, so in the case of a equals to 1, and this in the case of a is not equals to 1. A is not equals to 1. I take the first one. This is the one that you guys are probably most familiar with, right? So the way I set it up is that you notice that there's 1 here, so 1 times, right? And 1 is equals to 1 times 1. 1 equals to 1 times 1. Okay, so this factor 1 is equals to 1 times 1. And then we want to work with the number 6. Okay, 6 is factored into 2 times 3, negative 2 times negative 3, and negative 1 times negative 6, 1 times 6, and all these different possible factoring technique of factors. So I'm going to use 2 times 3. 2 times 3. So notice that how we set up initially. Okay, we set up initially by looking at a, right? ax squared plus, I think it's a little bit crowded here. So let me put it over here. Okay, and so this way we can have more, we can just show a little bit more. Okay. So a equals to 1 versus a is not equals to 1, right? So you can see if you look at the ax squared plus bx plus c form, a equals to 1. In the case of a equals to 1, 1 equals to 1 times 1, 6 equals 2 times 3. So this is the initial setup. And the rest, we play the rule very, very clearly in the following way. Okay, so what I would do is that I do the cross multiplication. Okay, I do the cross multiplication. 1 times 2 1 times 2 equals to 2. Okay, 1 times 3 equals to 3. Okay, so here I'm going to have 1 times 2 equals 2, and 1 times 3 is equals to 3. What do I do about these two numbers, 2 and 3? I'm going to add these two numbers. Okay, I'm going to add these two numbers, and this set of rule doesn't change. So once I add these two numbers, 2 plus 3, I will get a 5. Okay, this 5 is to be matching the number in front of x, which is the b, And obviously 5 does not match the -5. So this combination does not work. If it doesn't work, so factor you can see is a trial and error. Okay, trial and error. So it doesn't work, I'm going to try something else. How about I'm trying -2, right? I'm trying -3. Well, -2 times -3 is also +6. So 1 equals 1 times 1, 6 equals -2 times -3. I will do the cross multiplication one more time. This time I get -2, -3, and I'm still adding these two numbers, -2 plus -3, I'm getting -5. And this -5 finally matched the -5 over here. Okay, and this is the good news. Once we make the match, okay, we can now make our factors. Okay, we're making our factors. Hold on. This arrow doesn't work. I'm going to use a different arrow. Okay, so this arrow, the first row will give me a factor. The second row will also give me a factor. Okay, the first row will give me a factor like this. Okay, so parentheses. I'm making the factors. Okay, and the second row will also give me a factor. But how is the factor made? For 1, right, in the first row we have 1, -2. So we have 1 times x. 1 times x. Okay, -2. -2. Okay, -2. I got one factor here. Oops. Okay. X -2. The second row, 1, -3, I will still do 1 times x, this time -3. You see, we got the two factors. And 1 times x, of course, is x. X -2 will be one of the factors. Now I got an answer. So x -2 multiply x -3. So this is how it's been done. This is how it can be done. This is just one way to do it. I'm sure that many of you have learned other ways of setting up. In fact, all of these different ways of setting up to factor trinomials like this, they're all sourced from the same principle. Okay, we probably don't have time to talk about those principles, but anyway, you got the factor, and you can always check, you can always verify whether you got the right factors, right? All you have to do is just FOIL it. Okay, so FOIL, right? If you get exactly what you got, okay? If you get exactly what was given to you before the factoring, and you got it right, so we found the factors. Okay, the same technique could apply to a that is not equals to 1. Okay, so it can apply to a is not equals to 1. So I'm going to show you. So the same idea. Okay, So next, I'm going to clear this up. I'm going to do it, do another question. Okay, I'm going to take this one and factor. You can see the setups are very much similar. Okay, the setup is very much similar. Oh, sorry. I'm going to take this piece. I also don't want to make it too long. So let's look at the second example when A is not equals to 1. Okay, so this time you can see it's 2 times x squared. It's 2 times x squared. Okay, but 2 is equals to what? 1 times 2. 1 times 2. Okay, so let me just change this to color. Okay, 1 times 2. Of course, 2 equals to 1 times 2, -1 times -2, and you have these two options. For 3 equals to 3 times 1, right? -3 times -1. So here we're going to use 3 times 1. Okay, still the same setup and the same game to play. Cross multiplication. Cross multiplication. So 2 times 3 is 6. 1 times 1 is equals to 1. Okay, so I'm going to put these numbers together. 1 times 1 equals to 1. And 2 times 3 equals to 6. And then, of course, we're adding these two numbers. Okay, we're adding these two numbers, and 6 plus 1 is equals to 7. Okay, 7. And 7 matches the 7 right here perfectly. So we got our factors. We got our factors. So this the first row will give me a factor. The second row will give me the factor. And the way we make the factors are similar. The way we make the factors are similar. So over here, we're going to have 1 times x plus 3. Okay, the second row, we're getting the factor 2 times x. 2 times x plus 1. Okay, if you look at the setup and the way how it works, it's similar to what we did earlier. Okay, so we found the factors, and the way we use this, the numbers are similar. So therefore, now we got two factors. One is x plus 3, and the other one is 2x plus 1. Okay, 2x plus 1. So this is the technique to factor, quadratic form or trinomials. Okay, I got some exercise for you guys to do if you wish to practice. Okay, now the question is, we just mentioned a lot of these trinomials, when we factor them, they're always some quadratic form or trinomials that are very easy to factor, and you can work it out by trial and error. But sometimes it can be very frustrating that it's very difficult to find the factors. And then what do we do? Okay, from fundamental theorem of algebra, we know that every trinomial can be factored. Every trinomial can be factored. Of course, in some cases we get complex numbers. In some cases, we get real numbers. Sometimes we get radicals, right? How do we identify those cases? Is there a way that we can use to factor trinomials, then that we can get it done every single time without hiccups? And the answer is yes. There is a way that works all the time. This way, these two ways or one way we just worked, it doesn't work all the time. Okay, it doesn't work all the time. But for most of the academic questions, and yes, they do work, okay? And are there cases it doesn't work? Yes. And there is, as I said, there is a way that will always work, and I will talk about that another time. So this recording, I don't want to make it too long, and until next time, thank you for watching. And of course, you have some exercise. I'm going to put some additional exercise in the homework. Thank you for watching.